Next, let's take a look at how to compile multiple single C files using the make command. So you can have a whole bunch of .o files. In this case, we just have two, 1.0, 2.0, and then from those two, we create the one executable file. 1.0 depends on 1.c and 2.0 depends on 2.c. All you have to do for each case is just compile with the -c option. You don't have to say -o. You can, but it doesn't matter. That's the default. So when you say gcc -c 1.c, the default is 1.0, whatever this file is, .o. Okay, same thing for 2, and then the result of these two things is that we create two object files, 1.0 and 2.0, and then in this final step we link them together just like we did in well, 2 videos ago. We saw how to link two object files into one executable. So let's see how to do that in a single Makefile. This is advantageous because you don't have to type in all these commands. In this case, 3 commands that you would type in with all these different options that you have to remember. You just, instead of all of that, you put it into a Makefile, and now all you have to do is type in make 1, and everything is taken care of. When you say make 1, make is intelligent enough to see that 1 depends on 1.0, and it checks if that file exists. If it doesn't, it will go look for a rule for 1.0. This is called a rule for 1.0, and 1.0 depends on 1.c, and so it'll execute this command, which will create 1.0. Same thing for 2.0. It'll check if it exists. If it exists, it'll use it. If not, look for a rule, find it, and it sees that it should check the time of 2.c, and if necessary, perform all these steps. And once it's done with this step, it'll create the 2.0, which it then links together with 1.0 to create the executable. So let's take a look at how to do this. So here's our Makefile. We already have 1.0. I'm going to copy the 3 lines and paste it. Okay, there we go. Now I create the final rule for the executable. It depends on 1.0 and 2.0. And this one is going to create an output called 1 using 1.0 and 2.0. And you can put in comments like anything you want. Okay. Although it's not required that you list these files in this order, you can list it in any order. Make will search for the rules up and down. It's convention that you put dependencies earlier on. So if 1 depends on 1.0 and 2.0, you put those earlier on. That's just makes the Makefile more readable. Okay, I'm going to save this, and I'm going to say make 1. And there it goes. So the nice thing about this is I type in one command, which is probably more understandable to you, the programmer, than all these other lines of all these other commands that you have to type in to create that. Also, not only that, let's say you touch. Oh, let's try make again. Make 1 again, and it says make 1 is up to date. Now you change the modification time of, let's say, 2.c, and as you can guess, if you say make 1, it'll recompile 2.c to create 2.0, and then it'll create 1 from 1.0 and 2.0. So what have we done? We said if we were to type make 1 now after having changed, quote unquote, changed 2.c, after having changed 2.c, what make is going to do is if we say make 1, it'll check the times of these two, and well, it'll check the times of these two, and if you don't if these are older than this one, it won't. It'll just check then the times of 2.0. So 2.0, it'll check the time of 2.0 versus 2.c. It'll find that, well, 2.c is now newer because supposedly we modified it using this touch command. It will recompile this, and then it'll relink 1.0 and 2.0. Let's see if that works. Make 1. Sure enough, it said, okay, 1.0 and 2.0 are fine, but let's see 2.0. 2.0 depends on 2.c, which we just changed supposedly, and so it's going to recompile this. And so since it recompiled this is a new 2.0, and so it redoes this step. That's why we get these two lines, these two commands. So this is really nice in that if you have hundreds of files and you change just one, if you set up your Makefile perfectly, you'll just recompile just the ones that you need. You won't recompile every single file out of those 100. Just the one file that you changed will be recompiled and linked. The other 99 will be left alone because you don't need to make any changes. It does mean that you have to set up your Makefile properly with the right dependencies. Okay, you can make multiple targets. In this case, we're creating a debug version of 1.0 and 2.0 using the -g flag. And to do this properly, actually, the notes simplified the things that you should do. So let's get it right over here in this video. So if you want to make a debug version 1.0, let's make it 1.c and 2.c. You can do that. So what we'll do is recompile everything, gcc with the -g flag. -g, -o, 1, let's call it debug. 1.debug, 1.c, 2.c. Okay. So before I quit, let's just take a quick look at this. We're creating a new target called debug, and if we say make debug, it'll check 1.c and 2.c, and if those have been modified since let's just see if this works, because what I'm thinking of doing is having the target be something different from the result of this command be something different from the target. Let's see what happens if we do that. I'm actually not sure. Make debug. Okay, sure enough, it worked. It recompiled everything, but it made the result of that step is a file called 1.debug, not debug. So that's I want to do that on purpose just to see what happens. So we can run this. You can say gdb 1.debug, and we can list it, and it okay. So it only shows us 1.c. It's wondering what it would do. So it doesn't show us 2.c. That's fine. It works. Let's see if you run it, and everything works. So you can say break at 6, run it, and stops at 6. So everything does work. All right. Now the question is, can we touch 1.c and pretend that that has changed, and let's see what happens if we make debug. Well, it works. So we don't actually have to have a file called debug. So remember that usually the name of the target is exactly what's created by the commands whichever commands we use to create that target. In this case, I used a different name from the file that's produced as a result of commands in the make procedure. But it still worked. It still checked and saw that 1.debug is older than 1.c, and it recompiled. It redid this step. Okay. Okay, so now we can make multiple targets. We can say make one, that is the non-debug version, and make debug, that's the debug version of the same thing. Okay, make allows a use of a number of temporary variables. So you can say, okay, my compiler is GCC, and use uppercase letters. You don't have to, but that's the convention, is to say CC is an alias for GCC, and then what it uses, so it looks somewhat like shell variables in a script. It's not quite the same, but it's kind of similar. So when you assign an alias to a temporary variable, you just use it normally. You just say cc equals gcc, but then when you use it in your script, you have to use $ open paren, and then the name, the alias name or variable name, followed by close paren. So in this case, you're saying GCC is the compiler with options, in this case -G. So for a single file, maybe if you're just compiling one file, it's not that important, but if you have hundreds of files and let's say you want to have multiple options, say you use C compiler and then the C++ compiler in some cases, then it might come in handy. And you will see this in Eclipse. If you look at Makefiles in Eclipse, you will see this kind of structure. You can use a variable for the source file list, for example. Let's say you have 1.c and 1.o. You can set a variable source equal to all of the files, all of the source files, and then put that at the top line as $ open paren source. So this will be equivalent to putting 1.c and 1.h right in this first line. Well, I mean in this target line. Okay. You can put in a temporary variable for the destination too. So you can say destination is 1, and then now you've got these variables and basically everywhere. So you got the destination is a variable, and you made it 1. You made the list of source files a variable. There it is. So this is just like saying 1:1.c, 1.h. And here, this is GCC, this is -G, and this is the destination. So a nice thing about this is you won't get the destination is it's a good idea to do this, to use variables, just because sometimes people might misspell one or the other, like this one or this one. And this moving these using variables instead of the full name sort of removes that potential for errors. So use these variables for destination. That's a good use of variables. Make also has default suffix rules, and you will see this in Eclipse. If you use Eclipse for making C programs, here's a simple one for using C. You say -C -O. What this means is that there's a rule for generating an object code from a .c file. So this dependency is saying, okay, to create a .o file from a .c file, use this rule always. So from that point on, every .c, if you need to make a target, it'll use this rule. And so we'll finish up with a few more things having to do with functions next.